We're going to begin talking about a concept called limits. Limits, the concept of a limit is the idea of if I got really, really close to some x value, what would my y value be getting really, really close to? So we're not evaluating, we're not trying to figure out what the y value is at that x value, we're just trying to figure out what we're getting closest to. I have the definition here of what limit actually is. It's basically telling us if that our function is approaching some unique value, we call it L, all that's referring to is our y value. As x approaches some value, call it C, then the limit as x approaches C is L. This is the symbol of the notation of how we write it. So the limit as x gets really close to some C value, while we're following our function, gives us some y value L. So here are some pictures. So notice that if this is the x value that I'm looking at, this is my C, if I start to get really, really close to that C value in terms of my x values, what y value am I getting close to? Well, notice I'm getting close to this y value here, this L. That means my limit as x approaches C for this function is L. Works the same way. We do not have to have a continuous function. So notice this function actually has two separate pieces. It has this asymptote here, this other part here. Works the same way. As I get really, really close to C, I want to know what my L is. Well, notice I have an open circle at C. Well, that means that it's not defined at C. It doesn't matter that C is not actually defined. I'm still getting close to what y value? I'm still getting close to that y value of L. So let's look at some more concrete examples as opposed to looking at just the definition. And then these concrete examples might make this abstract idea make a little bit more sense. So let's say I start out with, here's my graph. So I have the limit as x approaches 3. So I want to know what's happening as I get close to an x value of 3. Well, as I get close to an x value of 3, notice that as I get closer and closer to that, my limit, my y value, is getting closer and closer to 2. So my limit as x approaches 3, notice I have written down, is 2. Let's look at a couple more concrete examples. Suppose here's my function. I want to know what's the limit as x approaches -1. So here's -1. I'm not asking what is my function equal to at -1. I'm asking what I'm getting close to. So I'm going to go up to my function. And as I get closer and closer to an x value of -1, notice I'm getting closer and closer to a y value of 1, 2, 3. So I'm going to go ahead and say this limit is equal to 3, even though it's defined as something else. One thing to point out about limits, if the left side of the function and the right side of the function do not approach the same thing, we say that the limit is undefined. So let's look at this function here. Notice as I approach x equals 2, so 1, 2. If I'm coming on the function from this side, notice my y values are getting closer and closer, to a y value of 2. However, if I approach from over here, if I approach from the right side of the function, notice my y values are getting closer and closer to -1. Since they are approaching two different things, I'm going to go ahead and say my limit does not exist. Often instead of writing that out, we just write DNE, does not exist. That is how you can determine a limit from a graph. What if you're not given a graph? Oftentimes it can be time consuming to graph out a function. So we have another method we use that we call that our table method. Evaluating a function with a table is a very nice fallback method. We are going to learn tons of different methods for evaluating functions. If at any point you ever get stuck and you're looking at all the different methods we've learned, because we're going to learn a lot of algebraic methods, and they're just not making sense and they're just not working, you can always fall back to a table. Tables are not ideal because they're very time consuming, not quite as time consuming as drawing the graph maybe, but they're still time consuming. But because it's a really good fallback method, I really want to make sure we all can do this. So let's say that I want to find the limit as x as it approaches -2 for this function. So if I was going to write that out, it would look like this. The limit as x gets close to or approaches -2 for my function x squared plus 2x plus 4 all over x plus 2, I want to know what is that equal to. Okay? So I'm going to pick some values that are really close to -2. So let's see, if I pick values over here that are close to -2 but bigger than it, and over here I'll pick values for x that are close to -2 but smaller than it. So let's say here I do, how about -1.999? That's really close to -2, but just a little bit bigger. And how about -1.99? And how about -1.9? I didn't leave the boxes big enough for my writing here, sorry about that. And then picking values that are really close to -2 but smaller. How about I do -2.001 and -2.01. Then what I'm going to do is, since I'm choosing these for x, I'll plug them into my function so I can evaluate for f of x. One thing to point out, I'm going to use my calculator to do this. Please remember that when you put something like this into your calculators, you put parentheses around your top expression and your bottom expression. So when I plug -2.01 into my calculator, I get 2.774. When I plug -2.001, getting a little bit closer to -2, I get 2.781. I don't know what's going on at -2, therefore there's my question mark. And notice if I did plug -2 in, it would give me a 0 on the bottom, so I'm undefined there. If I plug -1.999 in, I see I get 2.781. And if I plug -1.99 in, I get about 2.779. And then finally, if I plug in -1.9, I get 2.761. We will always round to 3 decimals. Okay, so notice I gave 3 decimal places on each of these. So I'm going to look, and I see that the closer I got to -2, the closer my values got to 2.781. So it looks like to me that I can say, comfortable to 3 decimals, that the closer that x gets to -2, the closer my function gets to 2.781. Even though it's undefined at -2, I can see that right away. I'm going to go ahead and say that it's getting closer and closer, so my limit is getting to be about 2.781. And then that's how tables work. So with graphs, we just follow the graph and see what y value we're approaching. With tables, we're going to pick numbers super close to whatever number we're interested in, find their y values, and hope that we can be accurate to 3 decimal places. If not, if these were not accurate to 3 decimal places, I would have had to pick something even closer to -2 on both sides and kept trying to get closer and closer. Also be aware that sometimes we are going to run into asymptotes. Remember, if we ran into an asymptote, this might look like these numbers are getting rapidly larger or rapidly smaller, depending on what direction our asymptote is traveling.